And now we have Andrzej from Nielsen. Let's get the presentation. Yeah. Cool.
Cool. Can you hear me well? Perfect. So my name is Andrzej Neścior. Today I'm going to speak about architecting for cost efficiency, mostly FinOps, but also Spark and Spot. First of all, I'm very grateful to be able to speak here and really excited. And thank you for coming. The weather is not great. And I'm also I'm sorry that the presentation is white. You should have told me. Okay. So just quickly about Nielsen, we are the global currency when it comes to trading between advertisers and providers. Like, let's say you watch something on Netflix and you get an ad somewhere in the background. Netflix is selling the time of the ad using Nielsen currency. We have our distinction is that we have a panel. And so maybe some of your family members, or you've heard about it. It's basically like installation in your house where people monitor, where we monitor whatever you watch to get accuracy on the currency. This is in 24+ countries. We are an AWS house, 6 primary regions, and then almost 20 auxiliary. We store more than 100 petabytes of data, and I've been with Nielsen for 3 years, and I worked on the data laking, where the data lake stores more than half of it, and we process and just massage 100 terabytes plus a day. Cool. So a lot of the stuff that Manny just spoke about is regarding the code optimization. And while it's very important, because obviously very unoptimized jobs may not even be able to finish, there is a curve to it where after few initial optimizations, you are spending additional hours, but you're not able to get the performance improvement you would like to get. And it's at this moment, it's not worth your time. So most of the time, you actually just care about those few parameters. Like I would say 80-90% of the time when you're setting your Spark job to run, you care about them. And I personally had situations where, going back to this slide, where I spent the entire day optimizing Spark job. It was running beautifully. I saved 15% of the money spent on it. But the next day I wake up and I get an alert because the data changed and the job started failing. And even if you have the perfectly optimized job, there is still the bill can go into 6, 7, 8 figures depending on the amount of data and the complexity of your job. So considering you've done all of this optimization with DataFlint, I'm not paid to do this, but yes, DataFlint is a very nice ally of people who deal with FinOps. You can take it to the next level, and we are speaking about AWS, but this is also like cloud agnostic, every cloud provider has this kind of thing. So there is a standard on-demand rate where you're basically running your EC2s and you're paying whatever AWS has on its pricing on their website. But then you can go through reservations or savings plans, which are either 1 year or 3 years, and then you have to commit to either you put some money up front or you put it not up front, but they offer significant savings. So reservations are up to 72%, and then from the savings fund 66%. And we are going to talk about Spot later, but just know that there is Spot that is extremely cheap but comes with its own pros and cons. So just considering, like, if your company have never done this, and you're like, okay, I'm going to just today purchase reservations because I'm going to save hundreds of thousands of dollars, I do not recommend doing that. Overall, this presentation is not a financial recommendation. So what I do at work and what I've seen working very well is whether a strategy, and this is the example for us was AWS introduced database savings funds just in December, They were very cool, like cover all the databases, whether it's RDS, whether it's OpenSearch. So we started with Sigmoid strategy, where we purchased just a little bit and quickly realized that they're not that cool. They're not offering enough savings, and they're only applying to 7th and 8th generation, and a lot of our stuff is on 6th generation. So usually one of these two curves is something you would like to follow. And when you're purchasing savings plans, there is a very cool analyzer view in AWS, which basically will show you the current commitment, what AWS recommends to you based on on the lookup period and whether you want to commit some money or not, and on-demand usage. And why, going back to this slide, you can see that the recommendation is to purchase monthly. Why do we want to do that? It's because you want to probably commit to 3-year savings plans because they offer the most. And then you end up in a situation where, like, I cannot predict what I'm going to eat tomorrow. So, not to mention what is the product your company will be doing in 6 months or a year. So you can see the offset phase is where you're overcommitted. You are still good because you're saving money. In the end, the savings are 60%. So even though you're, let's say, 30% overcommitted, you're still saving money, but you're overcommitted. So you're waiting with your purchases until your usage spikes or expires, and then you can see that after 3 years is the moment the usage, the first expiration happens, and you're like happy because now I'm perfectly committed and I can just follow the trend. So this is really, really important as you're doing FinOps. And as I mentioned, you can be overcommitted, and it's not really bad because not only there are seasonal spikes, but there are also like daily, weekly, holiday season. So this is, I had to obfuscate the numbers, but this is basically how it looks like in our company, and this is basically wasted money, and it's a significant amount, but just you have to embrace it and take it into consideration. And this is just a very simple example of automation what works for us, where we have just a Lambda. Lambda is pulling the data from Task Explorer. One way is through custom usage reports, which is basically what's powering all AWS invoices. And then there is the purchase analysis. We get an email every month. We are like, okay, this is something we can do. But obviously, I do not recommend taking the human out of the loop at this point now. Maybe at some point, agents and stuff like this. Additional tips, this is actually really interesting. So as a developer, what you should do is distinguish between the unblended cost, which is basically what's running on AWS, what's the pricing model from AWS, and the actual net amortized cost after all the discounts, because in every case, it could be like 50% difference. So just knowing that like there is a significant discount on what you're running is very important. Then some additional numbers in terms of computer speeds. This is based on my experience, something you want to consider. For us, actually, Spot brings only 12 to 15% more savings than complete savings plans, so it's not good. Considering the cost, which I'm going to talk about a little bit. And if your company has cash, go for cash upfront. And there is also this cool feature in AWS Customization Hub. It gives a lot of recommendations, not only for FinOps, but also like right-sizing EBS and stuff like this. But going back to this side, you can see the red spikes, which is basically rush hours, daily rush hours. You can see the weekends where the usage is actually down. So you want to, so even though you purchase savings plans and you're very happy, you have a lot of savings, they cannot cover that usage because then you're being overcommitted, you're paying a lot of money. So this is where Spot comes into place. And you'll see that a lot of these red spikes, depending on the company, obviously all of this is very company dependent, but you'll see that a lot of the spikes are actually where you're processing data. And as we mentioned, 90% of the data could be like single engine, but at least in our case, more than 50% of the data, no matter the size, goes through Spark, even if it's small or big. So, but anyone who can just anyone who tried Spot in extensive usage might have missed SLAs or paid actually more money. In our example, we had a 6,000 vCPUs job that we moved completely to Spot, and it seemed that initially, if your first initial runs, it completely worked perfectly fine, and then after, at some point, because, for example, in Spark, some of the configuration is past the rail. So it looked like it was processing, it looked like it was doing something, but because it didn't have enough cores and it got evicted multiple times, actually the job got stuck for 12 hours, and we paid for like 3,000 vCPUs for 12 hours without any progress. So when speaking about Spot on for Spark, we cannot skip Kubernetes. So Kubernetes comes with so many different reasons you want to use it, but it also supports the native scheduling parameters for Spot. So pains, node affinity, things like that, which we're going to cover. And then AWS actually not only started with EMR and EKS, but also released EKS Autonode, which has Carpenter, which we're going to talk a little bit about, also inside already, and it's very easy to manage. So overall, the AWS roadmap seems like they really want to push everyone to use EMR on EKS. Very important thing when you're considering moving to Kubernetes, and this is usually something that doesn't come up as the first aspect, but as you want to increase the Spot usage, you need to think about shuffle. And many obviously explained already what's shuffle, but on the standalone EMR clusters, we have something called external shuffle service, which basically runs as a part of yarn. And even though you're spinning up and spinning down and bringing down executors, it stays there to control the shuffles, to control the shuffle rights, and the executors can reference data. On Kubernetes, it's just not natively possible, so we are left with two options. Spark dynamic allocation shuffle tracking, which basically makes it so that executors will stay up and alive, and because the shuffle is happening on them, until there is something that still needs the data. And this is risky for Spot, because if you get evicted, you lose the data, and it also keeps more usage and more requests on the nodes, because you need to have more executors than you actually need for processing. And then there is remote shuffle service, and this is something really cool. Basically, the trick here is that you put the remote shuffle service, and there are multiple options, Teleborn, Unifold, AWS Cloud Shuffle, there was Uber Shuffle, which is not supported anymore. But you put the shuffle service on on-demand nodes, which is basically running 100% time on a separate node selector group, and you can move almost all of your executors to Spot them, because you don't really care if they you still care in, like, let's say 10% of the cases, but most of the time you don't care if the executors go down or not. The data is preserved, so the moment you get additional CPU, you can resume your job. And I already mentioned Carpenter. There are other solutions, but because AWS natively supports this one, I covered it. So normally, obviously, just by moving to Kubernetes, your Spark job should be spinning up faster, just because you're moving away from using user data scripts and booking everything at the runtime and the startup to pre-installing most of the stuff in Docker. But also, Carpenter supports basically, Carpenter, first of all, is very fast when it comes to spinning up instances. It also handles Spot evictions much better, and it will just automatically pick the cheapest option for your runtime. So you can get like the promised 90% of savings on Spot with Carpenter, and just a few additional configuration parameters for Kubernetes. So if we go back here, we have this. We agreed that shuffle should be the remote shuffle service, so you don't really care anymore about the decommissioning of executors in 90% of the cases, but there are still chances that, for example, your task is finishing up, and if you get the signal to the executor, it will still be able to finish it, or you're collecting data and keep caching it locally. So I still recommend we tried it, and decommissioning enabled worked for us. Then the default value for allocation, so basically how many pods, how many executors you can spin at once, is really low. So for most of the use cases, you want to increase the value. And then I strongly recommend, as you're migrating to Kubernetes, displaying it with pod templates. So basically, pod template is how you define your job. And from the infrastructure perspective, and things like just making sure you are running all of the pods in the same AZ or even zone, so you don't pay more money for network transfer, or you're picking out the drivers to on-demand node selectors is super important. And this is the bottom line. I think this example is a little bit over promising. So let's say you have a job that costs $3,000 a day. This is standard. Like I've seen many jobs in this range, and then you end up with a $1.1 million yearly deal. So with savings plans, if you cover 80% of your workload, you can save around 50%. Usually it's around 40-something%. That gives you a big bump. But to get to the lowest possible bill, you want to also use the spot instances. And so in our case, with those two together, we are able to achieve around 50% of the savings compared to the AWS pricing on AWS website. But obviously it will highly differ based on your company's usage. And also, I didn't mention, but every bigger company should or have enterprise discount with AWS. So basically, if you're a big customer, you're getting additional 20, 10, 15% discount if someone negotiated it well. Thank you so much. That's all.
Cool, thank you. We have time for 2 questions as well from the crowd. Cool.
Great talk. Thank you so much. Just one question. I'm very curious because this seems like it's very expensive to run a lot of these jobs, right? You work in a very sensitive environment in terms of SLAs and whatnot, sort of guarantees. You gave the example where you pre-allocated 6,000 CPUs, and it was kind of like anomalous. It just ran for 12 hours and recognized it. So I'm wondering, do you guys have any sort of like anomaly detection tooling deployed at scale, or kind of like preemptively catching these sort of runway tasks, or what does that sort of process look like for you guys?
Yes, that's a really good question. In that case, it was really hard to catch because it was still trying to process, right? It was still spinning up the executors, it just didn't have enough nodes, vCPUs, and it was constantly crashing. We do have different ways of monitoring. One of the very simple ones is basically we check logs, and if the logs are not appearing for enough period of time, we alert, and after some time we evict the job. And we also look at the metrics. So if it's either close to 0 or close to 100% for a certain period of time, that's also transfer fully written or incorrect.
Thank you.
So you mentioned about build pattern, right? So if a job A has some idle executors, can job B use those executors to run the job?
Yes, that's well. The executors will be killed, but in their place there can be another job scheduled with additional pods and in the same node, right? So we even have examples when someone is running an API, let's say fast API from Python on the same node as Spark pods. These are very, I do not recommend doing that just because Spark puts a lot of pressure on network. But it is possible. And then one thing I actually didn't mention, but going back to the shuttle service, being able to actually schedule shuffle service on a separate set of nodes with, first of all, on demand, but also faster EBS volumes. So we are provisioning input-output optimized EBS volumes because shuffle service is extremely disk intensive. So also it's like so good thing because these volumes are extremely expensive. So you don't want to attach them to every node, but just to the shuffle service.
Thanks, Andrzej. Again, if you have questions, you can chat them afterwards.
Thank you so much.
Thank you.